Once upon a time, there was an isolated population of Great Pyrenees dogs in the center of Canada. There were 100 total dogs in the population, 35 white, 48 spotted, and 17 brown. This population of dogs followed the Hardy-Weinberg equilibrium, meaning that their genotypic frequencies followed the p-squared 2pq q-squared rule. In this specific population of dogs, their genotypic frequencies follow the Hardy-Weinberg's rule because when you multiply them by the total population, you get the actual number of dogs with that genotype. For example, the p-squared value representing the big F frequency for this population is 0.3481, and when multiplied by 100, you get approximately 35 dogs, which is what this population has. This also works for the other genotypic frequencies, which are calculated from the allelic frequencies P and Q. P represents the dominant allele, big F, and Q represents the recessive allele, little f. One day, a group of dog breeders came across the population of dogs. These breeders knew that Great Pyrenees dogs can sell for lots of money, especially the purebred white ones. They saw this population and decided that they were going to keep breeding the white dogs, the ones with the big F genotype, and send the spotted and brown dogs far away. The breeders introduced a process called selection to the dog population, and this process has drastic effects on the equilibrium of the population. Each of the dog genotypes were affected by the breeders picking and choosing which dogs they wanted to keep reproducing, and because of this, they developed fitness values. The white dogs maintained a fitness of 1 because they had a 100% chance of survival, with the breeders making sure that they were staying alive long enough to reproduce. However, the spotted and white dogs developed fitnesses of 0.4 and 0.3 respectively. Their survival rates decreased tremendously due to these breeders. The unadjusted survivors are calculated by multiplying the initial frequency by the fitness. For example, the initial frequency of the brown dogs was 0.1681, and their fitness, due to the breeders, is now 0.3. Multiplying these two numbers gives us 0.05043. We then add all of the unadjusted survivor values together to get our average fitness, which is 0.59205. We then take all of the unadjusted survivors and divide each of those values by the average fitness. After all of those calculations, the new genotypic frequencies of the dog population after one generation of selective breeding are 0.58796 for the big F dogs, 0.3269 for the big F dogs, and 0.0518 for the little f dogs. The frequency for the big F genotype increased, while the other two genotypic frequencies decreased significantly. This is an example of directional selection, because the dogs with the most white, especially the pure white ones, are selected by the breeders to have a much higher chance of survival. These breeders continued to selectively breed the dogs until the little f allele that causes brown fur almost disappeared from the population. Even after just one generation of breeding, the frequency of the big F allele rose from 0.59 to 0.77, and the little f frequency dropped from 0.41 to 0.23. However, the breeders were caught and reported for their wrongdoings and were banned from Canada, allowing the dogs to mate as they pleased and return their population to the Hardy-Weinberg equilibrium once again.